So today we are going to practice multiplying and dividing complex numbers. So we spoke about complex numbers last time. We said that a complex number is a combination of a real number and an imaginary number. So for example, we have two complex numbers here. We have 4 plus 2i and 3 plus 5i. And I'm just going to go straight into examples and practice so that I'll do the 6 examples and then you'll try the 6 practice problems. It's pretty straightforward. You really just have to know your powers of I. So really here it's a binomial times a binomial, so we need to make sure we do 4 times 3, and then we do 4 times 5i, and then you have to do 2i times 3, and then 2i times 5i, okay? So 4 times 3 is 12. 4 times 5i is a positive 20i. Then I have 2i times 3 is a positive 6i. And then here I have 2i times 5i. Now 2 times 5 is 10. And then I times I is I squared. Now here's what's really important. You don't want to leave this I squared because remember, when I multiply and divide, I want to leave an a plus bi form. I don't want I squared here. It doesn't work. So to leave it in a plus bi form, I must tell myself, well, what is I squared equal to? And if you remember, I squared is equal to negative 1. So if I want to complete this, what's 10 times negative 1? It's actually negative 10. So if I want to now combine these, I have 12 minus 10, which is 2, and I have 20 plus 6, so it's plus 26i. So here is my final answer when I multiply a complex number by another complex number. So just keep watching. I'm going to continue doing some practice of these multiplication. Here's another example. So I have to do 5 times 2, 5 times negative 3i. Make sure you're doing all the signs. 6i times 2, and then 6i times negative 3i. So I get 10 minus 15i plus 12i. 6 times 3 is 18, negative 18i squared. Now since this is negative 1, this becomes positive 18. So I'm just bringing down the rest of the equation so that I can combine the correct terms. So 10 plus 18 is 28, and then a negative 15 and a positive 12, it gives me a negative 3i. So there is my answer there. I know I'm doing it pretty quickly, but I think you can catch on to what I'm doing here. So you only change anything that's more than a power of I. So we can leave these because it's in a plus bi form, but with the squareds, we have to simplify our powers of I, which we did that last week, if you remember. So now I have to do 2 times 2, then I have to do 2 times negative 3i, then I have to do 3i times 2, and then 3i times negative 3i. So 2 times 2 is 4 minus 6i plus 6i minus 9i squared. So look what happens here. So this is times negative 1, so this becomes plus 9. So when I want to combine these, okay, 4 plus 9 is 13, but then when I want to combine a negative 6i and a positive 6i, they actually cancel out, and I'm just left with 13. So look how interesting this is. A complex number times a complex number gave me a real number. In these other examples, it gave me complex numbers. Do you notice the difference? What is the difference? What made that happen? Some of you might notice. If you look at these examples right here, and I'm going to really point it out for you, look at these two. They are conjugates. Remember, conjugates means they're opposite. So I have a 2 plus 3i, and then I have a 2 minus 3i. So conjugate, so multiplying by the conjugate or the opposite, will cause you to give you a real number when you multiply them. So that's important to keep in mind because of when we will get to the division, and you'll see in just a moment why that is important. Okay, let's do one more example here. So I have 4 minus 3i squared, which means 4 minus 3i times 4 minus 3i. So then I got to do 4 times 4, and then 4 times negative 3i, and then negative 3i times 4, and then negative 3i times negative 3i. So I get 16 minus 12i minus 12i plus 9i squared. So this is technically 9 times negative 1, which is minus 9. So if I want to combine these, 16 minus a 9 is going to give you a 7. And then a negative 12i and a negative 12i gives you negative 24i. Okay, so there's your answer. Now, these last two practice problems, if you take a look here. Now, this is technically an imaginary number. It's not a pure imaginary, it's a complex number. Am I allowed to have imaginary numbers in the denominator? No. We said we treat this just like we treat radicals. You cannot have, so I'll put this in a note, on a, again, purple note. You cannot have imaginary in the denominator. So this is very important. So now, since I cannot have an imaginary number in the denominator, I'm going to need to do something. How can I rationalize? So therefore we need to rationalize the denominator. So we've been over rationalizing. So now that is where this becomes important. In order to get a real number, what do I have to multiply by? I have to multiply by the conjugate. So I have this problem, 1 plus I over 2 plus 3i. If I want to rationalize the denominator, I have to multiply by the conjugate, 2 minus 3i. Remember, whatever I multiply in the bottom, I have to multiply in the top. So I'm going to actually do this math at the bottom here. So 2 plus 3i, 2 minus 3i. We actually, I think, did the same exact problem up there. Yeah, we did. So you get 2 times 2 is 4. 2 times negative 3 is negative 6i, positive 6i, and then we get negative 9i squared. So really this becomes negative 9 times negative 1, so it's plus 9. So 4 minus 6i plus 6i minus, plus 9 means I get 13. So in the denominator, our new denominator is now 13. And then I'm going to do the work for the numerator in a different color. So let me do this work here. So 1 plus I times 2 minus 3i. So 1 times 2 is 2. Then 1 times negative 3i is negative 3i. Then I times 2 is positive 2i. Then I times negative 3i is negative 3i squared. This is negative 3 times negative 1. So 2 minus 3i plus 2i plus 3. So 2 plus 3 is 5. And negative 3 and positive 2 is negative 1i. So this now becomes 5 minus I. So really that's our final answer here. So you could either leave it like this, or some people like to split it because they like to try and simplify it. So minus I over 13. So either answer is a correct answer. But that is how you rationalize the denominator. That's how you get rid of an imaginary number from the denominator. And I'll do one more problem with you, and then you're going to try the practice problems. So to rationalize this denominator, I have to multiply by the conjugate. So the conjugate of 1 minus 2i is 1 plus 2i. So 1 plus 2i. I'll do this work first. So I should get a real number when I multiply these two. So 1 times 1 is 1, then I get plus 2i, then I get minus 2i, then I get minus 4i squared. So 1 plus 2i minus 2i, this is technically plus 4. So these will cancel out, and I'll get 1 plus 4 is 5. So my new denominator, I know I'm moving pretty quick, but I'm sure you can probably try and slow it down for yourself. So my new denominator is 5. And then my numerator, let me do this work here. 4 plus 3i times 1 plus 2i. 4 times 1 is 4. Then 4 times 2i is 8i. 3i times 1 is 3i. And then 3 times 2 is 6i squared. So this is technically 6 times negative 1. So this is 4 plus 8i plus 3i minus 6. So 4 minus 6 is a negative 2. And then 8i and 3i is 11i. So then my final answer here is this. Now remember, you can, you can always simplify if needed. So, or negative 2/5 plus 11i over 5. So if you want to write it like this, this is also acceptable because sometimes it does simplify. So really that's how you multiply and divide complex numbers. I did a few examples with you. So here are your 6 practice questions. So this is where you want to pause the video, try them out, and then come back and check your answers. Okay, so hopefully you were able to complete these problems. I have all the answers here. So here's number 1. Number 2, pause it wherever you need to. Number 3, because these are conjugates. Since these are conjugates, I got a real number. Number 4. Number 5, now most of you probably got this answer, 4 minus 16i over 8. But if all 3 of these numbers can be simplified or divided by something, so they all could be divided by 4, then you can simplify it. So it's 1 minus 4i over 2. Or if you split it, then you can even simplify this further. So any one of these 2 answers is acceptable if it's in simplest form. And then the same thing with number 6. It was you were able to simplify it by 3. So most of you probably got this answer, 21 plus 9i over 18. Now technically it's not wrong, but if the question asks you to put it in simplest form, you will have to simplify it the way that you see here or even here. Okay? So if you have any questions, please feel free to reach out to me, and have a great day, everybody.